In this lesson, we are going to learn about the features of an energy-efficient building. The Ministry of Energy, Water and Communications building is the first government low-energy office building. It was designed with various energy efficiency features, which results in efficient energy use without compromising users' comfort levels. The extra cost in incorporating energy efficiency features comes at only 10% of the building cost and translates into annual energy savings of up to 600,000 ringgit. The Ministry of Energy, Water and Communications Low Energy Office in Putrajaya is the first example of governmental building in Malaysia. It's a comprehensive list of energy efficiency features. The building demonstrates a comprehensive series of energy efficiency measures in the building architecture, in the mechanical and electrical systems, and through the implementation of energy management system. The energy index of the building is about 100 kilowatt-hour per meter squared per year, compared to the conventional office building energy index of 200 to 300 kilowatt-hour per meter squared per year. The government would like both the public and private sectors to also integrate energy efficiency features in their buildings, as they are cost-effective, environmentally friendly, and help to preserve our natural resources. In the MEWC building, the windows are primarily orientated to the north and the south. The north and south facades receive less direct sunlight compared to the east and west facades. Exterior shading reduces the amount of direct sunlight entering the building. This also minimizes heat gain in the building. There are two types of windows used: the curtain wall windows with exterior shading louvers in the upper floors, the punched hole windows in the lower floors. The punch hole windows have light shelves, which provide shading effects. The length of the shelves varies from 600 mm to 1000 mm, depending on the position of the windows. The light shelves allow light to get deeper into the building. The north facade has wider light shelves than the south facade, while the light shelves in the east are deeper to protect against the low morning sun. The windows constitute 25 to 39% of the facade area, depending on orientation. The west facade has virtually no window. The challenge of daylight design of the building is to design windows and shading which lets daylight in and prevent heat from entering the building, and reduces glare problems from the windows. In the MEWC building, these criteria are achieved through a combination of exterior shading and glazing. The window glazing is a 12 mm thick light green tinted glazing. The glazing allows more daylight but less heat through. The visible light transmission of the glazing is 63.1%, and the shading coefficient is 0.57. The main roof of the building is insulated with 100 mm polystyrene foam, compared to only 25 mm of insulation for normal buildings. The main roof surface is protected by a second canopy roof, which prevents direct solar radiation onto the roof. The walls of the MEWC building consist of 200 mm aerated concrete, and the exterior surface of the building is painted with light colors to reduce solar heating of the walls. The lightweight concrete walls have an insulation value 2.5 times better than that of a traditional brick wall, The roof is also equipped with rainwater harvest system to collect rainwater, which is then used to water plants. The atrium does not require air conditioning. The thermal flue chimney effect is used where a thermal flue stack on top of the atrium absorbs the heat from the sun, heating the air in the glazer's cavity. The hot air rises out of the cavity, pulling the air out of the atrium, allowing the fresh air to enter through the openings of the atrium. This process is repeated throughout the day and provides natural ventilation in the atrium. The atrium utilizes spray mist cooling with humidity sensors. The green area and landscaping at the atrium helps to reduce the temperature and create soothing effects in the atrium. The automatically controlled canopy provides shade in the atrium. The water wall at the atrium helps cool the lobby area while beautifying the surroundings. The water wall is powered by a small grid-connected photovoltaic system. The rainwater harvest system uses rainwater collected from the secondary roof for the irrigation system. The most intensive work areas are located near the facade, while less intensive work areas are situated at the center of the building. The use of daylight is maximized at the lobby area of the atrium. The building is equipped with energy-efficient air conditioning system. The temperature set point is 24 degrees Celsius. A decrease of temperature from 24 degrees Celsius to 20 degrees Celsius increases energy consumption by 33%. The temperature is controlled according to occupancy, schedule, and temperature setting. This provides better thermal comfort and good air quality. It also prevents excessive cooling in the building. Office equipment such as computers, printers, and copy machines use quite a significant amount of electricity and thereby increase the cooling load of the building. Therefore, special emphasis has been made in the procurement of energy-efficient office equipment, electricity consumption. The MEWC building is equipped with a comprehensive energy management system. The system allows continuous monitoring of the energy consumption in the different zones of the building. Cooling, lighting, and plug loads are monitored separately to help the energy manager in the management of energy of the building. Successful integration of readily available energy-efficient technologies in buildings can result in energy savings from the building and in a big reduction in the electricity bill. Energy efficiency is very cost-effective. It should be applied throughout the building sector, and the implementation of Malaysian Standard 1525/2001 for non-domestic building seem to be well justified.